Let's have a look at example 8. Now example 8 is pretty straightforward in the book, just using formulas. It says let H and G be events such that the probability of H is 1/3, the probability of G is 3 on 7, and the probability of H union G is 13 on 21. Find H intersection G. That's first, okay, we'll do that one. And then we'll do this one here. And determine if H and G are independent. Okay, so again on the previous page, we have a formula for events A and B, that the probability of A union B is equal to probability of A plus probability of B, that should be a B, minus the probability of A intersection B. Okay, so we're going to use that one. So we're going to change the letters to H and G. So we're going to say that the probability of H union G is equal to the probability of H plus the probability of G minus the probability of H intersection G. Okay. Now we already have some of this information, so we know that this is 13 on 21. The probability of H is 1 on 3. Now I'm getting this information from here. Okay. And the probability of G is 3 on 7. Okay, probability of G is 3 on 7, so let me just write that in. Plus 3 on 7 minus the probability of H intersection G. Okay, so from here we can move this and make it the subject over here. So we've got the probability of H intersection G equals 1 on 3 plus 3 on 7 minus 13 on 21. Common denominator here, lowest common denominator looks like 21, so we're going to put this as 7 on 21, 9 on 21 minus 13 on 21. And that's 16 on 21 minus 13 on 21, which is equal to 3 on 21, which is 1 on 7. So what we just found out was the intersection of H and G. Now it says here test for independence. Remember it says determine if they're independent. If they're independent, then the probability of H times the probability of G should equal the intersection of probability of H intersection G. Let's see if that's true. So let's multiply. This is what for independence, okay, for independent events, the probability of H intersection G should equal the probability of H times the probability of G. Okay, let's see what that equals. And the probability of H, they gave us that, is 1/3. The probability of G is 3 on 7. So that's 1/3 times 3 on 7. That equals 1 on 7. Okay, and as we can see, that 1 on 7 equals 1 on 7. That's what we're looking for. Therefore, they are independent. They are independent. All right? Okay, so let's check that. Now, what about this one here, the probability of H given G? Okay, we'll have a look at that one. Okay, now let's have a look at the probability of H given G. We're going to use this formula here, which is on the previous page. I know it's a bit hard to see here, but you'll be able to look at it the previous page to this example. The probability of H given G equals the probability of H intersection G over the probability of G. Now, expected that because we've seen that before. Whenever you're given these conditional probabilities, the probability of H given G, that's going to be on the denominator down here. Okay, you'll see that there. That's going to be on the bottom. Okay, now let's have a look at that. Work it out. We know already that the probability of H intersection G is 1 on 7, so we can write that. 1 on 7. We know the probability of G is 3 on 7. And therefore, that's 1 on 7 times 7 on 3 was equal to 1 on 3. Now, on the previous page, again, it says here, for independent events, the probability of A given B is equal to the probability of A. Similarly, the probability of B given A is equal to the probability of B for independent events. Okay, so what we're doing, we've already shown it's independent, but we're showing it's independent using the conditional probability formula as well. So what we'll do now is, we've got 1/3. Does the probability of H given G equal the probability of H? Let's have a look. It does, it's 1/3. And similarly, you'll find that the probability of G given H would equal to 3 on 7. So that's how they got to that answer there. I hope you've enjoyed this. See ya.